Okay, welcome to today's lesson. So we're going to be talking about or reviewing just a little bit about perfect squares, and then we're going to go on to talk about imaginary numbers. So let's just go back to our perfect squares real quick and do a quick review. So the square root of 1, if you think about it, we say the square root of 1, we know 1 is 1 times 1, which is 1. So what I'm looking for is a number times itself that equals 1, okay? So here we're looking for a number times itself that equals 4, and we know that that would be 2. So we say the square root of 4 is 2. And when I do the square root of 9, we know it's 3 times 3, and so the square root of 9 is 3. 16 is 4 times 4, so the square root of 16 is said to be 4. 25 would be 5 times 5, which is 5. So the square root of 5 times 5. And 36 would be the square root of 6 times 6, which is just 6. So those are our perfect squares. And you really need to know, I would say, at least the first 12 perfect squares on there. But the question is, and we deal with this more than we actually deal with the perfect squares, is how do I do it if my square, what's under the radical, that radicand, is not a perfect square? And I showed you how to take and prime factor it, and some of you liked that and some of you did not. So I'm just going to do the short way today. So what we're looking for actually is what perfect square goes into 8. So I'm going to look over here at what I've highlighted in green, and I want to know which one of those numbers goes into 8. And I don't want to know just which number, but I want to know which is the largest number, okay? And so hopefully you can look down through there and you say, well, I know 4 goes in there, and that's 4 times 2. So again, we've said the square root of 4, okay, right here. Square root of 4 is 2, square root 2. Okay, square root of 27. So I start with doing my 2 radicals, and then I'm going to look over to my list and I say which one of those numbers in the highlighted will go into 27. And I know it is 9, okay, and it's 9 and 3. So the square root of 9 is 3, and then I have the square root of 3 left, okay? So that's if I have underneath the radical a positive number. So here's my question though. What happens if I try to take the square root of a negative 4? Is there anything that I can take times itself and get a negative? And hopefully you remember that, you know, a positive times a positive is a positive number, and a negative times a negative is positive. Okay, so there's no way to get a negative without having a positive and a negative, and that can't happen if I'm asking you for the same number. A number can't be both positive and negative at the same time. Okay, so I look at that and I say, well, the square root of 4 has what we call no real solutions. Okay, which is great. But when we get to algebra, especially algebra 2, we need to be able to get past that. And so what we're looking for is something that will work. And how can we make it work? So think about it. If I didn't have the negative, and if I could break this apart and say, okay, well, I could say, take the negative out, kind of like factoring. If I could take that negative out and have the square root of 4, I know that's 2, but I still don't know what to do with this piece. Well, that's what we're going to talk about. So we're actually going to define the square root of negative 1 as an imaginary number, and so we call it I. Okay, we're going to call it I. So anytime you see that square root of negative 1, it is I. And so this simplified down is actually what we would write it as 2I. That I is telling me that I can't really do it to make a real solution, so it is now an imaginary solution. Okay? And again, we've defined that I as the square root of -1. And that's going to take us in to today's lesson. So let me scroll up to what we're going to talk about. So now if you'll remember, we have talked about, let me write it up here somewhere, that we had those boxes, okay, if you'll remember us doing this. And we had the whole numbers, and we had the natural numbers, and we had the integers, and then we had the rationals, and then we had the reals, okay? And then we also had a part of, which was also real, was the irrationals, okay? I should have put those over here. Let's just rewrite that just a second, okay? I don't like the way I did that. So we're going to just put inside here, okay, their irrationals, and those were I, remember? Because they are still real numbers. So what we're going to add to this today is this whole nother group out here that's not a part of, so they're not a part of all this. They're actually totally separate. And these are going to become our imaginary numbers, or we're going to call them complex numbers in a couple of days, okay? Or actually maybe today, okay? So let's go back then to this first sentence. The square root of a -1, we would say then it has no real solutions. Again, they are going to be imaginary. And that's why we invented the imaginary numbers, okay? So let's go back. And I wish they had given you a little bit better space, but we're going to do the square root of a -1 equals I, okay? And so the next thing we're going to talk about is, and I guess we could put that over here, okay, is what happens if we have I squared, okay? Well, if I have I squared, that really means I have the square root of a -1 times the square root of a -1. And if you go back to our definitions that we had earlier with perfect squares, and if you remember how I wrote that, let me just go back and show you. I said square root of 4 was 2 times 2, which is 2. Okay, so whatever is this is my answer here. So in this case, okay, what I have is 2 -1s, and so this is a -1. So the square root, I squared is defined as a -1. Okay, so you do need to remember these things. So I is the square root of a -1, and I squared is a -1. Okay, so I is the square root of a -1, but I squared is just a -1. Okay, and we're going to have to use that later on. Okay, so any number that can be written in the form of, and I'm going to just put BI, where the B is the real number. Okay, so we're going to have a real number and then imaginary, we're going to attach an I to it. So that might not make very sense, so let's just jump into a problem. So here's the square root of a -5. Again, since it has that negative, we're going to say a -1 and square root of 5. Square root of -1, square root of 5. I know that the square root of a -1, okay, that's up there defined, is I. I cannot simplify the square root of 5. That is as low as it'll go, and that would be my answer. Okay, square root of -36. So again, the first step is just to take the 1 and then leave you with the positive. I know the square root of 36 is 6, and the square root of 1 is I. Now, the way I wrote the radical over here and the way I'm going to write this one looks different. Okay? So technically, listen to this, technically, this is the way it should be written. The I should always be second. But let me explain to you. What I see kids do when they have I square root of 5 here is they end up making, a lot of times, that radical come too far over, and it looks like the I is underneath the radical, okay? Well, that's wrong. You'll never have an I under the radical, okay? And so I personally think it's better when you have a radical to put the I in front. That's only reason, okay? If you can write it very carefully and then put your I out here so it's very distinct, that would be the correct way of doing it. But again, I find the kids get in a hurry and they end up having that radical symbol come too far over. So please write it, if you have a radical, with the I in front. Okay? So next one, let's take 3. We've done that before. Now I'm going to break this apart and square root of 50. So I know that the square root of -1 is I. But here's the thing, the square root of 50, let's go back to what we talked about earlier. What is the perfect square in 50? And if you need to, again, I'll scroll back down for you. You could go all the way back down to this list, and which one of the numbers highlighted in green will go into 50? What's the biggest one? And hopefully you see that it's 25. And hopefully you didn't have to look at that list, but if you did, it's there. So 25 times 2. So what I have here, okay, write all the steps. 3 times I times the square root of 25 is 5 times the square root of 2. And we've had things like this before where there's multiple numbers out in front. So what we're going to do is we need to just multiply this together to simplify it. So I'm running into the next problem, that this would be 15I square root 2. And that would be your final answer. Okay? So I'm going to scroll back down because I want us to look at a few of these. So this is on down. Okay, and I'm going to do a couple more. So the square root of a -81 would be the square root of a -1 times the square root of 81. The square root of -1 is I. The square root of 81 is 9. Okay, but again, I write it as 9I. Next one, -4. I'm going to break this apart to -1 and 36. So the -4 is going to stay. The square root of a -1 is I, and the square root of 36 is 6. Now again, that's not simple because I need to go ahead and multiply it out. So -4 times 6 is -24, and then I just put the I on there. Okay? So that is those two problems there. Okay? And then I'm going to go on to talk about something else in the next video, but you're going to practice some of those.